Okay, grade beautiful tens. Yeah. All right, let's share this live. Grade tens, grade tens. Adds to grade tens, adds to. Okay, it's been a while, but grade tens, all the grade tens, Euclidean Geometry, grade tens. Wow, 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 wow. How has the Euclidean Geometry been, guys? If you're in grade 10, in your schools, have you started with Euclidean Geometry? Euclid, you beautiful. Grade 10 mathematics, Euclidean geometry, geometry of the Euclid, the geometry of the Euclid. No, they are still on trigonometry. Really? What? Trigonometry? Trigonometry? All right, so we're still on trigonometry. So do you guys want to do trig then? Could it be that my grade 10s want to do trigonometry? Yeah, because you see, the thing is, we had started sort of like a series on Euclidean geometry. I know that it's been a while since we've had a session, grade 10s. Understand that. Oh, okay. No, that's no problem. Okay, let's try and be a bit more. Let's try and not kill the let's not massacre the teachers. Let's show them mercy, just a little bit of mercy. Okay, show a little bit of mercy. Yeah. Remember, these are human beings. They're trying the best that they can under the circumstances. I think probably my own students would probably rail on me as well. Okay. But yeah, we do our best. They do their best. So okay, so we'll take it up with the grade 10 Euclidean geometry. So guys, okay, so let's look at the Euclidean geometry. I have already done foundational sessions on Euclidean geometry. The last time we ever had a session, we looked at some, grade 8 and grade 9 revision on Euclidean geometry. Okay, where lines are concerned, lines, we looked at triangles and just basically that foundational work. Okay, so today my intention was to basically move away now from lines and triangles, and we were now going to try and explore quadrilaterals, quadrilaterals. So the intention was today to actually look at quadrilaterals, okay? And whilst looking at quadrilaterals, hopefully, as we look at those quadrilaterals, then we could foundationally start looking at some of the basic problems that have to do with quadrilaterals, okay? Because quadrilaterals are important, okay? Very, very important, okay? Do we all know what a quadrilateral is, guys? Quadrilateral. And can we name the quadrilaterals we know? Okay, so hopefully quadrilaterals, we all know quadrilaterals are four-sided shapes. Four-sided shapes. They are two-dimensional, of course. Okay, meaning there's a horizontal dimension to them and a vertical dimension to quadrilaterals. But in essence, they are four-sided shapes, right? And the most important one that seems to have the most fame is the parallelogram. Parallelogram, okay? With its amazing properties, okay? The parallelogram, okay? Parallelogram. Very, very, very important, the parallelogram. Cannot stress how important the parallelogram is. Okay, so the parallelogram, we have the square, we have the rectangle, we have the kite, we have the trapezium. Okay, these are the quadrilaterals that we have. So I'm just going to draw some rough diagrams of these very quickly. Okay, let's say this is parallelogram A, B, C, D. Important properties of a parallelogram. Okay, I'm sure you guys all know that with parallelograms, the opposite sides, when we talk about opposite sides, what do we mean? AB is opposite DC, right? And then AD is opposite BC. So there are two things about a parallelogram. First and foremost, parallelogram, the opposite sides of a parallelogram are parallel. Okay? Yeah. Very significant property, this one. Okay? And in actual fact, whenever we in any way utilize this property to, let's say for instance, let's say we are given that ABCD is a parallelogram, then they say to you the side AB is 5 centimeters, and then they have X here, and they say what is the length of DC? All right. Oh, okay, this is not talking about parallel, something else. Look at another property. Okay, but I hope you get what I mean. Okay, but I'll get to that. Parallel, so if we put it in, that's one pair, opposite sides parallel, and then what we do is we put this symbol to indicate that those are also parallel. So you have both pairs of your opposite sides are parallel. For what? For a parallelogram. That's one of your important major properties of a parallelogram. 2, your opposite sides are also what? They are equal. Opposite sides are also equal. Both pairs of opposite sides are equal for a parallelogram. So that means Mr. here is equal to Mr. there, and Mr. here, please take note of my symbolism. All right, 2, 2 to ensure to basically mean that these two are equal, and 1, 1 line to indicate that these two are equal. The way that these two are equal is different from the way that these two are equal. The arrows indicate parallel lines. Okay, so this here is parallel in the horizontal direction, and these two are parallel in the vertical direction. Okay, so hopefully we understand the symbolism. And then obviously AB parallel, these two lines indicate lines that are parallel. This symbol here, AB, is parallel to DC. But of course, equal means the two sides are equal. Okay, and what I want to say is that whenever you use any one of these two in your acceptable reasons document, you can say op sides of parallelogram. Now you look at this. Op, this means opposite sides. Of, this symbol here, you write the parallel lines and then you put M. This here means parallelogram. This is like short form for parallelogram. So whether it's opposite sides of a parallelogram are parallel or opposite sides of a parallelogram are equal, this is your one time and all reason that you use. Op sides of parallelogram. Okay, so if you didn't know, I am here as the one who is conducting these sessions. I am exposing and revealing to you the secrets that are basically there. Okay, so we've only spoken about two properties of a parallelogram, and that is the opposite sides. Both pairs of opposite sides are parallel. Both pairs of opposite sides are equal. The other one that is very important to know is angle A is equal to angle C. angle A is equal to angle C. So the opposite sides of a parallelogram are equal. Okay? Not sides, sorry. The opposite angles. You see, now I'm saying sides. Remember, guys, that where two lines meet, we call this a vertex. And then a vertex, the gap, okay, is what we refer to as an angle. All right? So angle A is equal to angle C, whilst angle B is equal to angle D. So angle A is equal to angle C and angle B is equal to angle D. Okay? Okay, are we together? So the reason that we use there, we just say op angles of, once again, that symbol, which means parallelogram. Op angles of parallelogram. Please take note, guys. Angle A is equal to angle C. Angle B is equal to angle D. The way angle A and angle C are equal is different from the way angle B and angle D are equal. All right? Then, so that's the third property. The fourth property, which is important, is this one. It speaks about the, what do we call these lines? Let's see in the comment section if you guys know what these lines are. What is BD and AC? What do we call those lines? What do we call them? Let's see. Comment section. Let it rain, guys. Let it rain. BD and AC are called your... I'm waiting. Let's see who's going to actually tell me first. Yes. Yes. Woo. You don't mess with Pila Sunday. Okay. Yes, they're called diagonals. Diagonals. So what do we know about the diagonals of a parallelogram, Pilasand? Let's see if Pilasand knows the property that relates to diagonals where a parallelogram is concerned. In fact, why am I telling you all these properties? I should be having you tell me in the comment section and otherwise. Okay. The fourth defining property of a parallelogram is what? No, Kafiso, no. No, let's think a bit more. What do we know about the diagonals? No. Not they are equal. There's a defining property of the diagonals of a parallelogram that makes a parallelogram distinct. It's one of the major properties. There's 5 properties which we need to know, absolutely know, where parallelogram is concerned. Okay, please guys, please. So both pairs of opposite sides are parallel, that's 1. Both pairs of opposite sides are equal, that's 2. Opposite angles, both opposite angles of a parallelogram are equal, that's 3. The fourth one now relates to diagonals, and I'm waiting for someone to tell me what is the property that relates to the diagonals of a parallelogram. Yes, Mbali. Oh, my soul. Yes, Mbali. Mbali is the one. Woo! Yo, don't mess with Mbali. Mbali for sure. Mbali for president. But that's if Mbali is in the appropriate grade and is answering for the appropriate grade. If Mbali is in another grade, that's not grade 10, then I care. It's expected that he should have known. Okay, so yes, diagonals bisect each other. So I loved what Mbali said there. Mbali even explained what bisect means. Okay, bisect means they cut each other in half. So AC cuts BD, so that this is what you see. Are we together? Then BD does the same to AC. It cuts it, so that this is what you see. Okay, 3, 3, you have 4, 4. Okay, Hey, I hope we are together with this one. It's very important. Okay, diagonals bisect each other. So let's just say there was an E here. That means, in other words, AE is equal to EC, and BE is equal to ED. Okay, very important property, that one. All right, then the other last important property which I will refer to is one that relates to no diagonals of a parallelogram don't bisect at 90. Neo, 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 please. Okay, you need to, you see, and I like that Neo has made this guys. The diagonals of a parallelogram, they bisect each other. They do not bisect at 90 degrees. That's not for a parallelogram. There are other quadrilaterals that have those diagonals that bisect at 90, but the parallelogram is not one of them. So the other property is one pair of opposite sides are equal and parallel. One pair of opposite sides are equal and parallel. So in other words, you could take one pair of opposite sides, let's say AB. If we say AB is parallel to DC, and at the same time AB is equal to DC, then we know for sure that that qualifies that particular quadrilateral being a parallelogram. Okay, so all in all, guys, these 5 properties are key properties. Okay, so please, guys, repeat again. What did we first want to establish? We wanted to know what a quadrilateral is, and a quadrilateral is a 4-sided shape, 2-dimensional in nature. Okay, it's a 2-dimensional shape that is 4-sided. Okay, that's what's unique about a quadrilateral. A triangle and a quadrilateral are different. A triangle is also a 2-dimensional shape, but it is 3-sided. Quadrilateral is a 4-sided shape, and it comes from the word itself, because quad means 4, lateral means line, so it's 4-sided shapes. Okay, so parallelogram is one of those quadrilaterals. Okay, it has special properties. So if we look at the properties of a parallelogram, what do we know? The opposite sides of a parallelogram are parallel, firstly. 2, the opposite sides of a parallelogram are equal. Okay, and whenever we want to use this particular property as a reason for maybe the following. For instance, if we are given AB is 5 and then CD we are given it's X, and then we are like want to say X is equal to the side AB, and then we want to write our reason, then for both of these properties this reason is acceptable. Opposite sides of a parallelogram, whether both pairs of opposite sides are parallel or both pairs of opposite sides are equal, this is the acceptable reason that you are given in your acceptable reason document. Op sides of parallelogram. Okay, so these are those properties. 3, the opposite angles, meaning this angle and this angle, as well as this one with this one. Okay, so this one with this one, they are equal. Okay, and the way that these two are equal is different from the way that these two are equal. Okay, angle A is equal to angle C, whereas angle B is equal to angle D. Our acceptable reason from the acceptable reason document, whenever we want to use this to sort of like substantiate or verify or support why we are saying the angles are equal, we can say opposite angles of parallelogram. That's the acceptable reason. Okay, then 4, diagonals bisect each other. Which diagonals? The diagonals of a parallelogram, they bisect each other. Okay, now we also have there if we are using this one, okay, we can always use the reason diags of parallelogram. Okay, we don't necessarily have to say diagonals bisect each other. Diags is a term that is basically utilized in the acceptable reason document. Diags of a parallelogram. Whether it is to mean that the diagonals bisect each other, you can simply write diags of a parallelogram, okay? Or yeah, I'm just gonna end it there. Diags of a parallelogram. That's fine in brackets. Then the last property, one pair. Okay, remember, diagonals of a parallelogram bisect each other. What does that mean? This simply means that AE is equal to EC, because it's BD that cuts AC. It also means that BE is equal to ED. Why? Because AC cuts BD into half. All right. So what verifies that diagonals bisect each other is the fact that AE is equal to EC and BE is equal to ED. Right. So diags of a parallelogram. That's our acceptable reason in brackets. Then the last property, one pair of opposite sides are equal and parallel. Please guys, just one side. If you can prove that one side is parallel as well as being equal, then that means indeed that this is a parallelogram. Just one pair. So if you prove this one, that's fine. Or if you want to prove that one, that's fine. As long as you prove that one pair is equal as well as parallel. That is perfectly fine. So all in all, guys, you have how many properties? 1, 2. Okay. This property relates to the sides of the triangle. So that's why I put S. Sides are parallel, sides are equal. This here relates to A, the angle. Angles that are opposite each other are equal for a parallelogram. So that's A. And then 4 relates to D, okay, the diagonal. Okay, so for each shape, please guys, you need to know said. In other words, you need to know the property that relates to the sides for that particular quadrilateral. You need to know the property that relates to the angles for that particular quadrilateral. And you need to know the property that relates to diagonals for that particular quadrilateral. Sad. Oh, how sad you must be knowing that it is the sides, the angles, the diagonals that you need to know about each specific quadrilateral. So we just looked at the sides of a parallelogram, the angle of a parallelogram, the diagonals of a parallelogram, and we've looked at each property under SAD. 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 And we just had Happy join in the live. Happy just joined in the live whilst we are side, angle, diagonal for each quadrilateral. So the parallelogram, guys, as it relates to sides, opposite sides are parallel, opposite sides are equal. As it relates to angles, opposite angles are equal. As it relates to diagonals, the diagonals of a parallelogram, they bisect each other. All right. And then, of course, this also relates to the side, that you can just check if one pair of the opposite sides are actually equal and parallel. So this number 5 also relates to the side. Okay. So this could have been wormed in as our third reason underneath the side. So SAD, guys. SAD. SAD. All right. Happy. Hello, Happy. We're just doing sad. We're doing the opposite of you. No wonder you struggle with this topic. Why? Because SAD for Euclidean Geometry, Quadrilaterals. Woo-hoo. Right, so SAD, the sides, the angles, the diagonals. Every quadrilateral, guys, we need to look at it in terms of what does the particular quadrilateral, what does that particular quadrilateral say about the sides? Okay, so for the parallelogram, opposite sides are parallel, opposite sides are equal. one pair of opposite side is equal and parallel. That's everything on the sides of a parallelogram. What about the angles? The opposite angles of a parallelogram are equal. What about the diagonals? Diagonals bisect each other. Okay? Right. So I am going to just hold it right there, guys, for now, until further notice. And maybe you are wondering, hey, Bo, this guy, he's going to hold it right there for now until further notice. Yes. Do you know why? Because I'm the maths gamer. The maths gamer does not like it when people in his life are sad. So, in order to dispel the sadness so that we can be happy like HAPPY in the life, we are going to make sure that for all quadrilaterals, our sides, our angles, and our diagonals are things that we know when it comes to the property of each quadrilateral, so that we can be HAPPY. If we know how to be sad, then we can be HAPPY in maths. In other words, if we know our sides, our angles, our diagonals for our quadrilaterals, then we'll be HAPPY in maths. All right? Okay, so guys, that is just that. All right? And I want us to go now and navigate some space so that we can now go and check out some problems that relate to these properties that we are exposed to. Right, so just give me a sec. Oh, I got logo Lerato. That's not my fault. If you are cleaning, hey, Lerato. Hi, this girl. Lerato. Ay. Sometimes I feel like you are killing me. For real. Everybody's feeling like I'm going fast. Guys, what is this? Okay, you know what? Let's do this. What's crazy though is that you guys are saying I'm going fast, but wow, I've been saying the same thing over and over again. Okay. All right, guys, I hope you are with me. So I'm going to start from the very beginning. Grade 10, Euclidean Geometry. We are going to look at quadrilaterals. What is a quadrilateral? It is a four. Quad means four. Four-sided. Quad. Lateral means line. Four lines, right? 4 lines put together make a parallelogram. Put together can make a square. Put together rectangle, kite, trapezium. So we are going to look at the parallelogram alone. When we look at the parallelogram alone, we are going to look at the 5 properties that the parallelogram has. So, the first important property for your parallelogram has to do with the sides of a parallelogram. What do we know about the sides of a parallelogram? The first property, the opposite sides of a parallelogram are parallel. Parallel. So in other words, AB is parallel to CD. That's what parallel means. 2. AD is parallel to BC. So I'm hoping you can clearly see indeed that the opposite sides of a parallelogram are equal. Both pairs. This is the first pair, this is the second pair. Hence we have the first pair, AB is parallel to DC. Are they opposite each other, the sides? Yes. The symbol for parallel lines? Yes. AD is parallel to BC. So AD parallel to BC. That's the symbol. That is the reason we usually use whenever we have to find an unknown side for equal sides, for instance, because the other property that relates to sides is the fact that opposite sides of a parallelogram are equal. So AB is equal to DC as well as AD is equal to BC. They are equal in different ways. So if, for instance, this is 5 centimeters, that would be 5. This would be 10 and this would be 10. Opposite sides are equal. This reason, op sides of parallelogram, is the reason that is in the acceptable reason document in the exam guideline. So whenever we want to say, for instance, that DC is parallel to AB because we can see that this is a parallelogram, we can say that and then we can write this as our reason. Op sides of parallel lines, you can see with the M. This means parallelogram. Do we all understand the first and the second property as it relates to parallelograms for our sides? Are we together? Happy says yes. Lerato says yes. Hopefully your cleaning is now going great. Right. Now we can move on to the next property. This property, firstly, in fact, let us go to the last property, because the last property says one pair of opposite side. So I'm only looking at a single pair. One pair of opposite sides are equal. So that speaks to the equality of one side that is opposite, the pair of opposite sides that are equal, just one. Then the very same side is also parallel. In other words, the same side that you are speaking about that was equal, you are also saying it is parallel. That is another important property of a parallelogram, that one pair of opposite sides are equal and parallel. This also relates to the sides of a parallelogram. So one pair of opposite sides are equal and parallel. That means AB, you can say AB is parallel to CD, whilst at the same time AB is equal to DC. That is an adequate property for a parallelogram. So 1, 2, 3, all of these properties relate to the side of a parallelogram. Now, I hope we are officially good with S when it comes to the sides of a parallelogram. Now we need to move on to A, because part of being said is that we have the A in there and we know that the A stands for angles. What do we know about the angles of a parallelogram? Right? So if we go there now, we know that one of the distinguishing properties of the angles of a parallelogram is that the opposite angles, angle A and angle C in this case, as well as angle B and angle D in this case, the angles that are opposite each other are equal. Are we together? The angles opposite each other are equal. Angle B is equal to angle D. Angle A is equal to angle C. So angle A is equal to angle C. Angle B is equal to angle D. Angle A is equal to angle C. Angle B is equal to angle D. Angle A is equal to angle C. And the way that angle A and angle C are equal are different from the way that angle B and angle D are equal. Okay? I hope we are good. So, our reason that we can use, op angles of the two lines stand for parallel. The M is to say this opposite angles of parallelogram. This is in the acceptable reason document that you have whenever you want to basically state as an angle opposite for your particular parallelogram is equal to the angle opposite itself. So guys, please, this one relates to angles. The opposite angles of a parallelogram are what? Are equal. Let's go to number 5. This property relates to our diagonals, the D part of Z. So we need to uncover what does the diagonal have to say as far as the parallelogram is concerned. So the diagonals, what is a diagonal? It is the line that comes from one end, opposite end of a four-sided shape to the other. That's what a diagonal is. So diagonal AC and diagonal BD. There are two of them. What about those diagonals? The diagonals B bisect. This word bisect, someone explained it in the comment section and said bisect means to cut into half. So the diagonals, they what to each other? They bisect each other. So they do it to each other. They what? They do it to each other. It's not one doing it to the other or the other one doing. No, they do it to each other. It's like the one diagonal bisects the other one, while simultaneously the other diagonal does the same to the other. Okay, so the diagonals bisect each other. What does that practically mean? It means if you look at diagonal BD, it's going to cut AC into half. When it does that, what happens? AE is equal to EC. All right, that's what BD does to AC. But AC does the same thing. Okay, AC does the same thing. AC will cut BD into half, meaning BE is equal to ED. Right? So that's what it means when they say diagonals bisect each other. And then I said the reason that we can ever always utilize whenever we have to actually use that particular reasoning is diags of parallelogram. That's in the acceptable reason document. It's there for you to use. So guys, I don't know now if you are still confused, but the parallelogram makes a large part of the work that you do in your grade 10. So I am going to stop with the teaching of the concept of a quadrilateral just for the parallelogram for now. So for now, I am not going to explore the other quadrilaterals, but I do encourage and invite you to please go in your own time and explore all the other quadrilaterals so that you can know the properties of each quadrilateral very well. In grade 10, you must know the properties like you know your face. Okay? You must know the properties of a quadrilaterals, of all of them, just as well as you know your face. Okay? Most you know your face very well, right? You know your face very well. Every time you look into the mirror, you are not shocked at what you see in the mirror. So you must know the properties as well as you know your face. And if you know the properties very well, it will be well with you and in your soul. But if you don't, it won't be well with you and in your soul. All right. So please, my beloved grade 10s, know the properties very well. So I just want to look at a particular problem here so that we can explore what we have just done. So here is a problem. We are told that DELM, right? I'm sure you can see that, and I hope you can see it very well. We are told DELM is a what? Is a parallelogram. Now, we need to calculate. I'm going to draw the particular sketch just now. It says calculate the value of x and hence the sizes of the interior angles. Okay. Then 2, they said if DE is equal to 2 DM and ML is equal to 10 centimeters, determine the length of the other sides. Of DELM. Mr. Song, Mr. Ngoma, the song of all songs there. I hope you are well, Mr. Song, Mr. Song. Okay, so that's 2x, that's M, that's 10 centimeters. That's X, that's E, that's L. And then they have that arrow. Okay, so you're welcome. Then there we have it. It says DLM is a parallelogram. So very importantly, they are telling you it's a parallelogram. So the minute they say parallelogram, what happens in your head? Immediately in your head, you are like, all 5 properties are true for this shape. All 5 properties are true for this shape. Okay. So I just want to suggest an approach and a method whenever you are faced with problems like this. What you must do firstly is you need to first read the statement that is given. Okay, please guys, whenever you are given Euclidean geometry problems of this nature, you must first read the statement. We are told DELM is a parallelogram. So first read the statement, make sure you understand what it says. DELM, so you go to your diagram, you're like, okay, DELM, all right, I see, really it's there. Okay, then furthermore, what else? We are told that, or we are asked now, after the statement has been given to us, we are asked to now calculate the value of x and hence the sizes of the interior angles. All right, so terminology must be understood. So if we look at DELM, apart from what is in the statement, there is further information given inside the diagram itself. So we are given that angle D, for instance, is 2x, okay? Angle E is x, and then we are told that side ML is 10 centimeters. That is explicit in the diagram, but it was not mentioned in the statement. But of course, in the statement, we are told that this is a parallelogram, which means all 5 properties that we have learned about a parallelogram would be true for this particular diagram. Now, what are we asked? Calculate the value of x. Which x? That x. We're told to calculate the value of x, and we are told to hence. Okay, meaning utilizing what we have just calculated, we need to then calculate the sizes of the interior angles. Okay, I can see someone is bending. You know when you are busy with something and you can see someone is bending. But you. Yeah, can see Lerato though. Lerato, I thought Lerato was busy cleaning as well, but you. requesting
You are
very quickly there.
Hey, yeah. I'm done.
Lerato, hey, hey. Oh, you are done.
Yes.
Oh, okay. So why did you request now? You because I could see like whilst I was even busy writing, you were already requesting.
So, Agari, you're still explaining. So, I wanted to ask questions, and
Oh,
you do
okay.
not
Oh,
check the
you wanted.
comments.
I thought to me you wanted to answer the questions, not to ask.
Hmm? Najua.
Oh my soul, this is so funny. All right, so let's do it. You can go ahead. You can answer. Okay, I think that was not going to happen. All right, guys. So yeah, let's look at this. So DLM is a parallelogram, okay? And then we need to calculate the value of x. Okay, so there we have it. We have the angle D there, which is 2x. We have angle E there, which is x. And then ML, which is 10 centimeters. Obviously, x only relates to these two unknowns. So we need to look at this. And when we look at it, we need to look at it in light of the knowledge that we have from our geometry that we have from previous grades. Okay, so any ideas from people on the floor? What do you guys think? There we have 2x, we have x. There's lines that are parallel. Okay, is there a relationship perhaps between this 2x and this x as it relates to the parallelogram, or maybe as it relates to the lines that we have that are parallel? Because that becomes important, you know. So all of that understanding that we've learned in previous grades will assist us in being able to answer this particular question. Okay. All right. Okay. Okay, so hopefully we can see. All right, so I'm going to do this one example, and then after that, I will give you some so that you guys can do it, okay? So there's many ways. You see, what I love about geometry is that there's many ways to approach a problem. Many ways, you know? It all depends on what you see. And in what you see is the accuracy, all right? That's very important. So for instance, if you look at angle D and angle E, there is a relationship that I know that is there. Why? Because what I have forming here is the shape U. And these lines, LE and DM, they are parallel. So inside this parallelogram, these two lines, EL and DM, are parallel. And yes, Ray, what that helps me with is that I can see that the relationship between 2x and x gives me that co-interior relationship. Okay. So without even thinking much, I can then say the following. 2x plus this x will give me 180 degrees. And remember, when I write my reason is co-int angles, and then semicolon. I need to then state those lines that are parallel. Okay, those lines that are parallel. That means DM is parallel to EL, because those are the two lines by which my U shape is formed. Co-interior angles. Do you still remember that? And I hope we can remember it very well. So that's very important, because even if in this diagram the parallel lines were not written in, because it says DELM is a parallelogram, I know that all the 5 properties that pertain to a parallelogram would apply, and they would assist me in being able to move in getting my value of x. So it's important to know the properties. Hence, I started out in this live session and we looked at the properties of a parallelogram. Both pairs of opposite sides for a parallelogram are what? Are parallel. Okay. Okay, so because of that, there are relationships that exist between parallel lines, all right, as we learned in grade 8 and 9. There's the co-interior angle relationship, which is the U-shaped relationship. There is the alternate angle relationship, which is the Z-shaped relationship. And then there is the F relationship, which is the corresponding angle relationship. And every time, guys, we utilize this reasoning, we must make sure that we state the parallel lines, which is very important. So if we then solve this, we get 3x is equal to 180 degrees. And what's beautiful is that we've utilized every x unknown that is in this diagram in the hopes of being able to calculate the value of x. Right? Now we can go ahead and divide both sides by what? By 3. So that gives us x is equal to 60 degrees. Who can fight against the accuracy and the beauty of this approach? Anyone? Surely, guys, you can see, Moss. It works. It really does work. Okay? Really does work. Okay? Maybe someone else would have said, sir, no. Instead of doing it this way, I saw this. I saw that angle E, okay, angle E and angle M, they are opposite each other. Maybe someone else would have said angle E is equal to angle M, which is equal to X, right? Okay, and then they would have written the X in there. Okay, then after that, they would have said this angle, okay, this angle and this angle, we can add them together because they see the U-shaped relationship in this way. Maybe someone wouldn't have seen the U relationship in this way, but they would have been able to see the U relationship in this way. All right. Okay. But remember, now what you would have to do is you would have to say 2x plus this x is equal to 180 degrees. Let's just say it was someone that had seen this way. Then they would have said equal to 180, still co-int angles, and then their parallel lines would have been DE is parallel to ML. Okay, that would have been perfectly fine. Still, this would have led us to what? This would have still led us to the answer x is equal to 60 degrees. Okay, or someone else would have seen it this way. They would have said angle D is equal to angle L, which is, this means this would also be 2x. Then they would take this 2x plus this x equal to 180 degrees. This would be their reason. They'd solve for x. That's also fine. Okay. Oh, let's not forget this one. We would say op angles of parallelogram. Let's not forget the reasoning. Very, very important. You see now, I start employing my reasoning that I've just learned recently. Op angles of parallelogram, because this is the symbol that I use to write parallelogram in short. Okay, I hope that makes sense. Okay, so either or, guys, at the end of the day, we still are able to get x is equal to 60 degrees, because remember, for every statement that we give that is new, there must be an accompanying reason for that particular statement. We can't simply write something and not have a reason to support what we've just said. Okay, now Limo, hello Limo. If we move on to the next question, number 2, because that was 1, actually not number 2, but hence, because this question is continuing number 1, it says hence the sizes of the interior angles. The sizes of the interior angles. So remember, we started it off this way. We got x is equal to 60. So that means now we can actually write in the actual values of x there. Okay, x is 60. So we want all the what? The sizes of the interior angles. Remember, what does the word interior mean? It means the inside angles, the angles inside the parallelogram. So that means we want the value of angle D, the value of angle E, the value of angle L, the value of angle M. So let's go. What do we know so far? We know that angle, we can say now, angle E is equal to angle M, which is equal to 60 degrees. Why do we say that? Remember, x is 60, so that means angle E is equal to angle M, right? Angle E and angle M are equal, which is equal to 60 degrees. Why? Opposite angles of parallelogram. Okay, so done. We know these two angles. Then what's left now? We need angle D. So angle D is equal to 2 times, remember, in the place of x, since we know that x is 60 degrees, it means 2 times 60, which is 120 degrees. Okay, no reason, because all we are doing here is we are simply substituting the value of x in the place of what? In the place of x where angle D is. 2 times 60 gives me 120 degrees. Now the only thing that's left now is angle L. Therefore, angle D is equal to angle L, which is equal to 120 degrees. What's the reason? The reason is op angles of parallelogram. Okay. All my interior angles, do I have them? Oh, yes, I do. Oh, yes, I do. Angle E is equal to angle M, definitely, which is equal to 60 degrees. The reason why angle E and angle M are equal is because these are opposite angles of a parallelogram. Then angle D is 2x. So angle D is equal to 2 times 60 degrees, which is 120. Okay, and then angle D is equal to angle L, which is equal to 120 degrees. Reason? Opposite angles of parallelogram. Okay, so remember, guys, as I said to you, I'm just simply using the acceptable reasons as stipulated in the document that you guys utilize in grade 10, 11, and 12. So when we are in grade 10, 11, and 12, it's very important to sort of like adopt that uniformity of statements as per the exam guideline. Because remember, when you are in grade 12, your teacher is not going to be the one that's going to mark your paper. The person who's going to mark your paper is someone that you don't know, who is from a different place, and who is a teacher of another school. But they will be conforming to the standardized way of marking all papers as per the reasons that are stated in the document that is called the acceptable reason document for Euclidean geometry. So you may have used certain reasons in the past, but what I'm trying to really encourage you to do is to really try and acclimatize yourself to the reasoning that is stipulated in the exam document. Okay, yeah, for uniformity. Okay, all right. So I update here my diagram. That's 60 degrees. That's 60. That's 120. That at the end is also 120. All of it. Okay. Now, let's move on to the next question. The next question says, if DE is equal to 2 times DM, where's DE? That's DE. If DE is equal to 2 times DM, the question is, and ML is equal to 10 centimeters, determine the length of the other sides of DELM. So let's start here. ML. ML is 10. Okay. Obviously, ML is centimeters, that is given to us, right? Okay. So we know ML is 10 centimeters. ML is opposite DE. So we can then say DE is equal to ML, which is equal to 10 centimeters. What's the reason? Op sides of parallelogram. Op sides of parallelogram. We know that if we want to say the opposite sides are equal, we can just use the acceptable reason statement or the reason op sides of parallelogram. Okay, and it's as simple as that. So ML we were given as what? As 10 centimeters. Then we know that ML is opposite DE, which is actually equal also to 10 centimeters. But remember, there was a statement that we were given here, and that is DE is equal to 2 times DM. Are we together? So we are given that thing, all right? Okay, now DE, which is here, we are told is equal to 2 times dm. So what we do is that we know that DE is equal to 10 centimeters. So we substitute in the place of DE 10 centimeters, 2 times dm, 2 times dm. dm we don't know, but dm we want to find. So that means the relationship between 2 and dm is multiply. So what do? We divide both sides by 2. Why do we divide by 2? We use the inverse, the multiplicative inverse of 2. So that leaves us with dm isolated on the right. And then what's 10 divided by 2? It is equal to 5 centimeters. Okay, so we know that dm is equal to 10 divided by 2, which is 5 centimeters. Furthermore, we know that dm is equal to, let's go back to dm. If dm is 5 centimeters, as we've just found it, it means now we can find what el is. dm and el are opposite sides. And as opposite sides, these sides are actually what for a parallelogram? We know that opposite sides of a parallelogram are equal. So that means dm is equal to el, which is equal to 5 centimeters. What is the reason? Op sides of parallelogram. Done. Okay, I think that was everything, wasn't it? That was everything. Okay, that was everything. That was everything. Okay. Now, any questions from anyone about anything? Okay. All right. That question fully answered, done and dusted, finished. Okay. Now, I don't know if people have questions, please ask your questions. All right. This was the initial question. We were given DELM is a parallelogram. Okay. Calculate the value of x and hence the sizes of the interior angles. Okay. Yeah. Can you give more than one reasons? Now we try to stick with a reason. Okay. Okay. Just give a reason. All right. If you write a particular statement, write one reason. Don't give more than 2 reasons. I mean, why do you want to do that, right? You just want to give in the exam, after you've given a particular statement which is new, then you need to give an appropriate reason. Just one appropriate reasons, not many reasons. Don't complicate your life, and do that. Okay. Then Lerado, your comment earlier on. Yeah, I hope that's a clarity in that one though. Okay, so like I said, the reasons, guys, let's try and familiarize ourselves. I'm really for making sure that we lay the foundation so that come grade 12, we don't have to try and learn new things in grade 12. The easier we can make life for ourselves now, right now, and the more we can sensitize even our educators at school that, I learned this thing, in a respectful manner, that, just there's this document that I learned about, the acceptable reason document, and it seems like an important document, and the reasoning, Yes, Neo, you can, definitely. In Euclidean geometry is unique because of that, okay? Euclidean geometry is unique because of that. What is unique about Euclidean geometry is the fact that whenever you do something in Euclidean geometry, it must be accompanied by reasons. No reasons may lead to a loss of marks, okay? Yeah, especially when you write, remember, a new statement, okay, in the progress towards answering a question. When you write a new statement, you must have an accompanying reason, okay? If it is given, then you write the reason is given. If it's given in the particular diagram, then you write given. Okay? In the diagram, PQRS, let's look at another example. Okay, before I give you guys your own. Okay, so you can see here, I have not really explored other quadrilaterals. We are still looking within the parallelogram, because there's a lot of questions, okay, that obviously we can get that are examined from the perspective of a parallelogram. Hence, you need to know the properties of parallelogram. Okay, so let's be sharp when it comes to those properties. So in the diagram here, we are told PQRS is a parallelogram. PT is perpendicular to QR. And I'm going to sketch the diagram now. PT is equal to 5 centimeters. TQ is 2 centimeters. PS is 10 centimeters. Calculate the length. Calculate the length of VR. Yeah, if people are going to complain that I don't go live, Lerato, then I don't know what more people want, you know. All right, so okay, there 90. Okay, there, there, 5 centimeters, 2 centimeters, we got T, we've got P, we've got Q, we've got S, we've got R, we've got 10 centimeters, we've got V. Yeah. Okay, and all that is asked here is simple. All right, what is asked here is that we calculate. You can use functions in geometry. No, not that guy cakes. No, functions. No, my little. No. Not in geometry, Euclidean geometry. No. Okay, so in the diagram, PQRS is a parallelogram. Okay, PQRS. So we know that this is a parallelogram. So immediately, the minute that you say it is a parallelogram, you think of all the properties that relate to a parallelogram. The fact that opposite sides are equal, opposite sides are parallel, diagonals bisect each other. All right, those are all there. Opposite angles are equal, you know, those are all there. They may not be in the diagram written like there, you know, with all those symbols, but this diagram, you know, because there are diagonals inside, it means the diagonals bisect each other. Okay, because we are told this is a parallelogram. Now you see, someone who doesn't know the properties will never see the 5 properties embedded in the diagram, you know, but that's why it's important to know the properties. So now furthermore we are told that PT, here's PT is outside of the parallelogram, it's perpendicular to, PT is perpendicular to, okay, I think this is supposed to be TR, not QR, sorry, my bad. Okay, in fact, let's just say TQR, my bad. So PT is perpendicular to TQR, okay? PT is equal to 5 centimeters, good, that's already in the diagram. TQ is equal to 2, good, that's already in the diagram. And PS is equal to 10, good, that's already in the diagram. Calculate the length of VR. Do you guys remember what I said? We need to make sure first that we read the statement. After we've read the statement, we must make sure that we transfer all the information that is here in the statement. We must transfer it to the diagram, because at the end of the day, it's the diagram that we are going to use to be able to answer the question as to the length of VR. All right, so it's important to transfer the information. So someone like me, I'm going to check now, where is VR? VR is from here to there. But even before I continue, this is what I'm going to do. I'm going to make sure I put this. Why am I putting this? because I know PV is equal to VR. Why? Because we are told that this is a parallelogram, and you know something about the diagonals of a parallelogram. So this, I'm putting it in there, all right? More especially for PR. The thing is, SQ will bisect, yeah, SQ will bisect PR. Very important. Likewise, PV will bisect SQ. You see? So all of these things are important because diagonals bisect each other. Remember the three things that I need to make sure I know about the properties of each quadrilateral, especially now the parallelogram. As it relates to sides, opposite sides are equal, opposite sides are parallel. As it relates to angles, opposite angles are equal. And then as it relates to diagonals, diagonals bisect each other. And I know what that means. I'm asked to find the length of VR. So it should be cooking quite nicely if you ask me. All right, should be cooking quite nicely if you ask me. So let's do this, guys. Are you ready for this? Yeah, I hope you are ready for this. I don't know if you're ready for this because it's definitely ready for you, that's for sure. So let's start this off. First things first, if we look at the parallelogram, can you see this PS and can you see this QR? All right, I hope you can see this PS and this QR. Remember, I want VR. So PS and QR, these are opposite sides of a what? Of a parallelogram. Why? Because we are told PQRS is a palm. So first things first, I'm going to say PS is equal to QR, which is equal to 10 centimeters. Why are we saying that? Opposite sides of parallelogram. Okay, are we together? Then I'm going to go to my diagram. I'm going to put in the 10 centimeters. Okay. Right. Now, there is something that I can see in this diagram, which makes life very, 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 very interesting. Okay. I hope you guys can see it too. Do you see that PT PTR? Do you see PTR? Can you guys tell me what you see for PTR? What do you guys see? PTR. Can someone tell me what they see? What is that? PTR. PTR. No. Don't put a question mark, Neo. You must right angle. You must put the right thing, my leader. Ish. You see, the thing is, I worry about people that put question marks because it's like they are still asking me the question. I asked you a question, you are still asking me the question back. You see, so that question mark should have been replaced with a exclamation mark, command, right angle, sir. And then you put that exclamation mark as an indication that you know what you're talking about. So let's be careful about that. Neo, I hope you're getting my heart there. All right. I need math students that are clear and confident. I need that from you. Once you know something, guys, you see, I don't wait. It's not me wasting my time when I'm explaining properties to you and all of these things. When you know what you know, stop being, don't play this game of, say, is it, could it be? No. You must be clear and confident, sharp as the knife, So please make sure that you are a bit more confident with what you have to say. So yes, you guys are 100% correct. PTR is a right angle triangle. Can you see? Now I'm going to say in triangle PTR because I want to turn the person who's marking my work to, I want to turn their attention to this triangle. Hey, guys, do you see that all the geometry from previous grades is coming back? At the beginning of this live lesson, did I do anything on right angles? No, I didn't. But people like Lerato who were here when I first did, when I first started this grade 10 Euclidean Geometry series, will know for a fact that we touched on and we looked at the properties that relate to earlier things that we did in earlier grades. So for instance, the right angle triangle, you can see I have this side, which is 5 centimeters, which is PT. Okay, and I have TR, all of it, because this 2 centimeters plus this 10 will give me the full length of TR. So what then can I use, guys? Because that helps me then to see, can I get PR? What is PR in this right angle? What do we call PR for this right angle triangle? And what then can we use to find PR? Yes, not that guy. Mbali. Woo! Woo! Woohoo! All right, you guys have got it down. Yabo, look at this, guys. Now, this is what I'm talking about. Okay, so remember, what is PR? Very good, God's favorite child. PR is the hypotenuse. Okay, do you guys remember what the theorem of Pythagoras says? The theorem of Pythagoras says the square of the hypotenuse side is equal to the sum of the square of the other two sides. What are these other two sides? It is PT and TR. The sum of the square of these other two sides will give you the hypotenuse squared. Okay, so what we do then, very simply, we just say PR squared is equal to PT squared plus TR squared. Why are we saying that? We must write our reason. Very important. Okay, it's in the acceptable reason document. Whenever you use Pythagoras, you must write the reasoning Pythagoras. Now we can substitute PR squared. That's exactly what we want. We want PR squared so that we can find VR, because there on PR, VR is there. So we're going to say PR squared. What's PT? PT is 5 squared. What's TR? It is 12 squared. That gives me 25 plus 144, which gives me 169. So PR squared. Okay. We adopt the positive. Okay. We know that whenever we take the square root on both sides for an equation, we write plus minus. But we know that a length can never be negative. We are going to assume the positive length. And then the answer is 13. 13 what? Centimeters. Remember, that is PR. Okay. PR is equal to 13 centimeters. What do we want? We don't want PR. We want the length of VR. Where is VR? Here is VR. VR. Okay. Remember, we learned that diagonals of a parallelogram, they bisect each other. So let's be honest, QS, okay, QS, okay, very important thing. My friend, Sakile, you are saying you must also note how you got PR. Yeah, very key, very key. All right, the way that we got our PR there, all right, hence I was even saying to the learners, very importantly, that right angle triangle. And in that right angle triangle, all right, we utilize Pythagoras. And because of Pythagoras, we are able to get the length of PR. Okay, so very key, Mr. Sakile, very, very key. So PR is 13 centimeters. But there's something else that we know almost, that if PR is 13 centimeters, then this diagonal, it bisects PR. In other words, I liked what Elena said earlier on. What does the word bisect mean? It means that this here, this PR is cut into half by QS. So what can we write here? We can therefore say that VR is equal to 13 centimeters. We divide it by 2. And when we write that down, guys, we can simply say the reason is diags of parallelogram. Okay. Yeah. So we can just write diags of parallelogram. They know what they know about the diagonals of a parallelogram. So I'm writing this as well as seen in that acceptable reason document. 13 divided by 2, we get 6,5 centimeters. Give VR into it. Give VR. Mishima. Okay. Okay. All right. Okay. I hope we are good, good people. I hope we are very, very good. Very, very good. Very, very good. Okay. Yeah. I hope we are very, very good. All right. Okay, so I'm just gonna go over it one more time. So in the diagram, PQRS is a parallelogram. Remember when we said when it is stated that something is a parallelogram, it means all the 5 properties of a parallelogram are implicit or are implied in that parallelogram. Okay, so yeah, the last part, or this last part. Okay, remember PR is what? It's 13 centimeters, the entire PR. But we want the length of VR. Okay, yes, I'm gonna upload this there. Okay, the entire length is VR. So remember, guys, this in other words means that VR is equal to, let's just say it then, VR is equal to PR. VR is equal to PR. VR is equal to PR. Why is VR equal to PR? Diagonals of a parallelogram. VR is equal to PR. Diagonals bisect each other, right? Then we can say that, so I'm going to lengthen it out. We can say that PR is equal to, what's PR equal to? PR is equal to VR plus PR. But didn't we say VR is equal to PR? So that means we can say VR plus VR. Why can we say VR plus VR? Because we said VR is equal to PR, diagonals of a parallelogram. So in the place of PR, no man, VR plus PV. What am I saying here? Sorry, my mistake, guys. VR is equal to PV. What am I saying here? Okay, my mistake, guys. So VR is equal to PV. Why are we saying VR is equal to PV? Diagonals of a parallelogram. Okay, I'm sorry, guys. That was my mistake, okay? VR is equal to PV. Remember, the diagonals of a parallelogram, they what? They bisect each other. So we say VR is equal to PV, diagonals of a parallelogram. The entire length of PR, okay? The entire length of what? Of PR. The entire length of PR is equal to VR plus PV. The entire length of PR is equal to VR plus PV. But remember, we said VR is equal to PV, which means in the place of PV, we can write VR. So that's why we say in the place of PV, we write VR. So PR is equal to VR plus VR. But that PR will be equal to 2VR. And then in the place of that VR, remember, we got what PR is. PR is 13, 2VR, and then that allows us to do what? To divide both sides by 2. And then we get VR, which is equal to 6.5 centimeters. Okay, maybe that's how you can see it step by step. Okay, just that here we shortcutted the process because we saw about, oh, PR, if PR is 13, and then obviously this diagonal is bisecting, in other words, it's cutting this PR into half. We can just say VR is equal to 13 centimeters divided by 2 to get 6.5. Because PR is 13 centimeters, we're cutting this PR into half to get the length of VR. So we can just say VR is equal to 13 divided by 2, we get 6.5. Straight up from the actual thing, okay? So I hope that makes sense, okay? Okay, so 2 approaches, maybe a little bit longer, but you can see the substitution as it applies. And then this one, a little bit more intuitive from the diagram itself, just based on what we see. Okay. All right. Yo. Now that was a problem and a half, guys. All right. But yeah, yabo. All of this is the sweet munchy meal, and for what is it for Euclidean geometry. So the Euclidean geometry is not hectic, guys. It's nice, it's cute, it's beautiful, it's delicious. Tseposta also agrees, Mulefesta also agrees the Euclidean geometry is sweet, it's nice, there's nothing much to it. So yeah, man, I believe that if we have the properties down, we should have no issues, challenges, problems at all. All right. So I'm going to give you I'm going to give you some game challenge so that people can go be challenged. Are you guys ready to go and be challenged? Okay, so if you don't mind, I'm going to just remove the comment section for a while so that as I write them out, you guys can. Just gonna remove the comment section a bit. Determine the sizes of the interior angles of parallelogram X, Y, Z, W. X, Y, Z, W, 2x minus 30 degrees, 2x plus 10. Okay, I think that's it. That's the first one. Okay, determine the sizes of the interior angles of parallelogram X, Y, Z, W. Okay, sound sweet enough, guys? Okay, number 2, another one. PQRS is a parallelogram with angle P equal to 60 degrees and PQ equal to PS. Calculate the sizes of angle R, angle S1, angle Q1, angle Q2, and angle S2. The diagram okay, PQRS, as it says, is a parallelogram with angle P is equal to 60 degrees and PQ is equal to PS. Calculate the sizes of angle R, angle S1, angle Q1, angle Q2, and angle S2. Three, B, D, E, F, G is a parallelogram calculate the size of the interior angles. Okay, that's number 3. Yeah, and I think I'll do the last one. In parallelogram, PQRS, PQ is equal to 50 centimeters, and the L is a point on PS such that PQ is equal to PL, and RS is equal to SL. Determine 1. Right, I think I'm going to have to sketch this diagram here for this one because of my lack of space, because I want to have the diagram there. So what did we say the diagram is? PQRS. Have L there, have 1, 2, 3, we have 1, 2, 1, 2, so they want SL, then to the perimeter of PQRS. Right. Okay, so I'm just gonna go back to the first one. I don't know, for screenshot purposes. So that's the first one. Determine the sizes of the interior angles of parallelogram X, Y, Z, W. The sizes of the interior angles of parallelogram. So hopefully we understand what that entails, okay, because we looked at examples that are similar. Number 2, we said PQRS is a parallelogram with angle P equal to 60 degrees and PQ is equal to PS, PQ is equal to PS, calculate the sizes of angle R, angle S1, angle Q1, angle Q2, and angle S2. That's number 2. Then, if we're coming to number 3, don't mind this diagram. DEFG is a parallelogram. Calculate the size of the interior angles. So this is number 3, guys. Okay. My number 3 is with this diagram. DEFG is a parallelogram. DEFG is a parallelogram. Calculate the sizes of the interior angles. Okay, the inside angles. Then last question, this one. In parallelogram PQRS, this one, PQRS, we are told PQ is 50 centimeters, L is a point on PS, there it is, L, such that PQ is equal to PL, right? And RS is equal to SL. Determine SL, the length of SL, and the perimeter of PQRS. Okay, guys, I think that's it. Okay, you guys can do that for your game challenges, and we will see each other at another time. We'll pick this up at this point, and when we come on next time, we will continue from there. Okay, guys, I hope that session was worth your time. It was worth your while, you know, worth your time, worth your while, worth your few hours that you spent. Maybe you would have been doing something else. Yo, there are people that are like amazing. I need to say, Busisiwe, you are a star. You are so amazing. Okay, you are so amazing. I am so pleased. You've been here like, yo, for long. You've been here from inception. Lerato, amazing. Tando Yengosi, awesome. All right. At least you are the people I can see that have been there proactive. Have Lusanda, Opel, Vibe, Manchasa, Kina, Katleho, Jura, Dona, Sakile, of course. In the comment section, always giving that comment or two. The Vibe comment or two there. Not that guy, Kex as well. People who came in just as we were continuing on as well, that commented there and there. Those that followed as they actually caught on to what we were doing as we were going along. You guys have been phenomenal. Like, ish. Another one, please, on 6 o'clock. No, guys. Hey, I have a life. Ginny, I have a life to be lived, guys. Hey, these people, they think to me I'm mad all the time. No. I can't do another one at 6, guys. Ay. Me now, I have to go and tend to other things. So thank you so much, guys, for joining in. Please do these game challenges, and don't be afraid to actually, if you finish them like in the next few minutes or so, you can always just send me an inbox or send me a message and let me know that you're done. You can screenshot, take pictures, send them through, and I can check out what you did. Okay. On the last question, we can't see what do they say such that PQ is equal to PL. Okay, that's what they're saying here. Such that, okay, because remember they're saying L is a point on PS. So L here is a point on PS, such that L is a point on PS such that PQ is equal to PL. That's what they're saying. Okay, and PRSR is equal to LS. Okay, so then now you need to determine SL. Okay, and then the perimeter of PQRS. Okay, so hopefully that is clear now, clear enough for you, right? Yeah, guys, as we build that confidence in the Euclidean geometry, because it is easy. Sis, man, Euclidean geometry is so easy. This Euclidean geometry for grade 10 is weak. All right, so we start from these numerical type questions, and then as we go along, we'll go and look at proof type questions. You know, questions like where they start giving us variables and we need to actually find angles and sides in terms of a particular variable. Also, where they ask us to prove that PQ is parallel to this, to prove that this particular shape is a parallelogram, prove that it's a rhombus. Remember, we are still yet to look at other properties. This particular live session was just looking at the properties of a parallelogram, and then obviously the application of those properties in various problems, not forgetting our grade 8 and 9 Euclidean geometry. So important. You see, Pythagoras came up, it creeped up on us, guys, just like that. And imagine if someone is totally asleep to Pythagoras because they're like, I am in grade 10, we in grade 10, we do this now, you see, we do quadrilaterals, you know. No, guys, you must still have your vibe. You need to have, you need to whip out your, you know, yeah, you need to whip out your stuff, your good stuff, even in this Euclidean geometry that you are doing. That foundation is so critical. Okay. See, look. They're even asking you here, perimeter. Do you even know what perimeter is? Have you forgotten? You see, these things are things we need to remember. Okay, guys, thank you so much. Okay, lots and loads of maths love to you guys. And remember, maths is a game. Let's play it wisely. Let's play it funly. Let's get the levels. Let's level up. You know? Yeah. Just level up, guys. Let's level up. Tina, we are playing the game to level up so that we can be able to have access to future opportunities that are available for us. It's very important. It's very key. And just to my brothers and sisters here that might be on the platform, you've seen me do my live session and you're like, man, I think I could do the very same thing this guy is doing, man. Establish a reputable platform for kids and learners to come in. There are so many learners in the country, guys, that are struggling with mathematics and other subjects. If you have the skill, you have the time, you have open time, you have the resources, you've been gifted in speaking and being able to articulate, explain simple concepts, please, guys, go on, help out the learners. They need it. I cannot begin to state how many learners need the mathematics intervention, because some of them, they are sitting there in their respective schools. Teachers are absent. Teachers are not attending. Some of them are deprived because of a weak system and the managerial system in their respective schools. So therefore, there's that thing of lack of accountability, and therefore the term, the syllabus is passing by, and learners are feeling very defeated because no teacher in sight. But I also want to encourage our learners to become self-sustained, self-sufficient, and self-reliant kind of learners. The kind of learners that don't need an educator in front of them, but the kind of learners that are so hungry for education, they go and look for it where it can be found. And some of you have found this platform, and we are rolling together. We are doing the maths is mathsing, and it's amazing. So guys, take care. Have an amazing one. And thank you so much. It was lovely. It was beautiful. Love all of you. Cheerio, tootles. Goodbye. I'm out. Yo. Thank you for the follow. Thank you for the follow. Thank you for all the follows, guys. Thank you so much for all of them.